Hi, welcome back to this channel. In previous video, we already discussed about predict the product form for the electrolysis of molten and also water using the inert electrode. So in this video, we are going to focus on the predict the product of the electrolysis for concentrated and dilute aqueous and NaCl. So, and then in the next video, only we discuss about the electrolysis of aqueous sodium sulfate and also predict the product of the others electrolysis. Okay, let's start with the electrolysis of concentrated NaCl solution using the inert electrode. So once we see the word solution, basically we have the idea that we are going to add some water so that becomes solution and the physical state is aqueous. Therefore, now there are water molecule Na+ and also Cl negative present in the solution. So then now we have to know what are the species going attracted to the cathode. So we know that cation attracted to cathode. So but in this case, beside from the cation, water also attracted to cathode. So this one is a bit different compared to molten salt and also water. In molten salt, there is only one cation and there is no water molecule. So only Na+ will be attracted to cathode. And then at that condition, there is no choice. Na+ automatically will be discharged. But now here we have two choices. One is Na+ and then another one is water. So between these two, only one will be selectively discharged. That means we will only choose one from these two to discharge. Okay, so now we are going to write down the half equation over here. As we know again, the reduction will happen at the cathode, and then species with the more positive SRP value will be selected. Then now we look at the half equation. This is the SRP value for sodium, negative 2.71 volt. And then we need to look for another half equation which involves water. And then because of water is selectively discharged, let's say water is selectively discharged at the cathode, hydrogen gas will be produced. So when you refer to the SRP value, you have to choose one half equation with the water and also hydrogen gas. So this is the one that we choose from the SRP series, where you can see here we have water and then the product is hydrogen gas. And the SRP value is negative 0.83. So at here statement state that SRP value should be more positive, then they will undergo reduction and happen at the cathode. So that means now we have the two choices. We are going to choose the one which with the more positive SRP value. So in this case, negative 0.83 is more positive. So then now here we can say that water are selectively discharged. So if the water is selectively discharged, so the half equation is H2O. So we recall again how to balance the equation. Let's say you didn't memorize this half equation. As we know, water if selectively discharged at cathode will produce hydrogen gas. So now we will notice that left hand side have oxygen, right hand side doesn't have oxygen. So we balance it using the OH negative. So now number of hydrogen is not balanced, so we put 2 in front of OH negative. Since now have 2 oxygen, so we are going to put 2 more of water. Then next we are going to balance the charge. The total charge at the left hand side at this moment now is 0, while for the right hand side is 0 plus 2 minus negative 1. So then we know that we need to add electron at left hand side. So how many electrons we need to add? We need to add 2 more of electron. so that here also -2. Both left hand side and right hand side, the charge are balanced. Now this is the part of the summary in your notes. So if you have cation, then you have to try to ask yourself, is it the cation is group 1 or group 2 metal ion? So like this case, yes, because Na plus is group 1. So if this group 1 ion is present, so water will be selectively discharged. If there is no group 1 element, for example, we have a Cu2+. So more concentrated cation is reduced. So in this case, we here mention concentrated NaCl. Let's say here is concentrated copper 2 chloride. So copper 2+ will be selectively discharged. Okay, after settle for the cation, then we are going to look at the anion side. So anion going to attracted to anode. So as just now, beside from the Cl negative will attracted to anode, water also will be attracted to the anode. So at the anode, the reaction happen is the oxidation. So the SRP value have to be more negative or be so-called less positive. So you use either one terms that you prefer. So personally, I will prefer more negative terms. Okay, so here now we have chloride ion. So we have to look for the half equation which consists of chloride ion, which the SRP value is positive 1.36 volt. While the other one, we look for the water, and then the half equation, because of the water are attracted to anode, so we see the O first, so means that we have to find another half equation with the water and also the oxygen gas. So because these two half equations we get from the SRP value, so both of these half equation will be in the reduction form, but then should be no problem because we need to choose which one will be selectively discharged based on the SRP value. So in this case, SRP value for the Cl water is more negative. Okay, this one, okay, I try to use another color. So this value it is more negative. Okay, however, when we look at the diagram over here, in this case, we going to use inert electrode, so yes. So, and then from here, we know that the ion selectively discharged is the Cl negative. So, we're going to say yes also. Then the conclusion here is say that the one which is more concentrated will be oxidized. So now we have Cl negative and also water. Because of just now in front of there, we say that it is concentrated NaCl. So that's why in this case, Cl negative will be oxidized because of the high concentration of the Cl negative. So as usual, after we know which one is selectively discharged, we need to write the half equation. So this time, because the reaction happen at the anode is oxidation. So when we want to write the half cell equation, we can refer to the SRP series, but we cannot copy exactly the same because in the SRP series, the half equation is in the reduction form. So now this one is the one that we choose. Then now when we write the half equation, we're going to write down Cl negative aqueous, 2 more of Cl negative aqueous, and then going to produce 1 more of chlorine gas and 2 more of electron. So to show that the oxidation process is happening. Okay, now we're going to continue with the electrolysis of dilute NaCl. solution using the inert electrode. So the difference with the previous example that we discussed is the concentration. Just now is the concentrated solution, pekat. So and then this one is dilute and NaCl, which is NaCl. Okay, so similar as the previous case, in this solution, we can find that there are water molecule, Na+ and also Cl negative. So as usual, Na+ and also the water will attract to the cathode. So reaction happen at the cathode always is reduction, and we have to choose the one with the more positive SRP value. So same as the just now, both Na+ and also water, we look for the SRP value. One is negative 2.71 and then the other one is negative 0.83. So between these two values, we know that negative 0.83 is more positive. So in this case, even though we check with the summary given in the question in your notes, in the cation, is there group 1 metal ion? Yes. So if yes, water will be reduced. So matching with this, SRP value more positive also will be selectively discharged. So in this case, water molecule are discharged and the half cell equation, since here is already in the reduction form, so you can directly copy down here. Okay, basically now we know that the anion and also water will attracted to the anode. Oxidation will be happen there, and we will going to choose the one with the less positive SRP value or more negative SRP value. So both value given here is 1.36 and 1.23 respectively. So then from here we know that 1.23 is more negative. So in this case, water will be selectively discharged. If we want to state the factor, we're going to say that because water is in a higher concentration, but again generally we not prefer to mention that water has higher concentration because concentration of water cannot be aided, or that means that the concentrator of the water cannot be changing. Okay, so that's why maybe we can say that concentration Cl negative is lower. Okay, then now here we know that the reaction happen at the anode is oxidation. So that's why this half equation, which is in the reduction form, have to reverse or switch so that 2 mole of water become the reactant and then produce 1 mole of oxygen gas and 4 mole of H+ by losing 4 mole of electron. And then we copy back the half equation that we wrote in the previous slide. This is the half equation at the cathode. Then you will notice that at here, anode lose 4 electron, but at the cathode only gain 2 more electron. Therefore, the half equation at the cathode will be multiplied by 2. So this one becomes 4 more water, 4 more electron, 2 more H2 and 4 more of OH negative. Then next we know that 4 more of electron and 4 more of electron can be cancelled out. So after that we try to write the overall equation. So 2 mole of water plus 4 mole of water, here we have 6 mole of water and then produce 1 more oxygen gas and 2 more hydrogen gas. Then you will notice that 4 more, here we have 4 more of H+ and then 4 more of OH negative, which we able to form 4 more of water. So then here we notice that the water presence at both left hand side and right hand side. So we know that this one can be cancelled out and left 2 more of H2O. So and then it will be balanced to produce 1 more oxygen gas and 2 more of hydrogen gas. So to make it clearer, the overall equation is 2 more water going to produce 1 more oxygen gas and 2 more hydrogen gas. Okay, before we end this video, let's have a simple and quick summary. So basically, in this video, we focus on the factor of concentration. So both examples that we discussed are using similar electrolyte, which is the NaCl. The difference only from the concentration. One is concentrated NaCl, and then another one is dilute NaCl. So now we want to know what are the ions that will be selectively discharged at the cathode. So both Na plus and H2O are maybe I can use here. Both Na plus and H2O are attracted to the cathode. However, only H2O will be selectively discharged at the cathode due to the SRP value. While for the anode, both Cl negative and water will be attracted to the anode. However, if the concentration of NaCl is higher, Cl negative will be selectively discharged. But if the sodium chloride that we use is in dilute sodium chloride, water will be selectively discharged due to the concentration of Cl negative is too low. So with this simple table, I hope that you can get the difference between the electrolysis of concentrated NaCl and also dilute NaCl. So in next video, we are going to discuss about electrolysis of aqueous sodium sulfate and also 1 or 2 more examples. So that's all for this video. Thank you for watching. See you in next video again.